Okay, so for this video, we are going to review drop factors and how to calculate total parenteral nutrition, which is also known as TPN. I did put in a couple of videos that I pulled from YouTube as well that might help you, but I'm going to go through this lecture as well. So first of all, why do pharmacy technicians need to understand flow rates and drop sets? Um, it's yeah, I know you guys won't ever be infusing an IV, and you'll never have to calculate how fast you're going to flow it or flow in an IV, or you're never going to have to set the pump up. But being aware of appropriate flow rates for various drugs and IV solutions can really play an important role to ensure that mistakes are not made. So calculating these two pharmacy calculations are typically required by the nursing staff, but they are responsible for infusing the medications. But as a pharm tech, being aware of these flow rates to make sure it makes sense, make sure there's no errors written, is really important so they can be addressed. Now, large volumes, such as parenteral solutions, are usually administered to patients either by allowing the solution to slowly drip, by gravitational flow, or through infusion pumps. And this is an image of a gravitational flow where we don't see these much anymore. You use a roll clamp to actually adjust them. And then this is the infusion pump, which we are much more familiar with, where we type in and the machine will actually do the proper flow rate for you. This can be used sometimes in thicker solutions or other reasons, and that's why they still calculate them. So gravitational equipment requires a drop factor measured in drops per milliliter, and that's always, whenever they say a drop factor, let's say the problem asks for a 10 drop factor, the drop factor units is drops per milliliter. So a macro drip set is 10 drops per milliliter, 15 or 20, which produce pretty large drops for an IV set, and you would count them in the drip chamber. A micro drip or mini drip set is 60 drops per milliliter, and that's a standard. So if they ever say use a mini drop set or mini drip set, you're going to use 60 drops per milliliter, and they may use that. We use this for pediatrics or adults that are critically ill and on medications that have a narrow therapeutic index. So meaning that, you have to keep them in a really tight range so you don't cause toxicities. And then draw factors are located on the outside of IV tubing packages. So I took this image from a book. This is kind of showing your drop sets and the drop it's counting. So the larger the drop, that's a macro drop, 10, 15, and 20, and then a mini drop is a 60, so the drop is just smaller. And you look at it through this drip chamber and it's controlled by a roll clamp. So how to calculate drop sets. Dimensional analysis is the easiest. It's easier than trying to memorize formulas or which formulas to use when. So if an IV set, let's look at this problem. If an IV set is calibrated at 20 drops per milliliter, how many drops would deliver 60 milliliter solution? So here I set it up as dimensional analysis. We're going to start with how many. So we're going to start with 60 milliliters, and then you want to cross your milliliters off. So let's see if I can get this in here. So if we're gonna cross this off and cross this off, we're left with drops, and that's what we're looking for is drops. So 60 times 20 is 1200, and that's your answer. So remember again, whenever you're doing dimensional analysis, pay attention to what you're looking for and put it over here so they match. Okay, and then go with what you need to what you start with and how you can cross those units off. Okay, so next here, what if an IV set calibrated at 12 drops per milliliter is used? How many drops per minute would be administered would need to administer the IV solution to a patient receive 200 milliliters of IV solution infused over 2 hours. So once again, we want to start with our volume over time. We always want to start there. So we want to start with it. We're doing a total of 200 milliliters and we're doing it in 2 hours. So we want to get to our answer of drops per minute. Okay, so we want to put that over here, drops per minute, and now we want to move to that because we're in milliliters per hour and we want to move to drops per minute. So what in our problem can we get rid of milliliters and change it to drops? Well, right here it says 12 drops per milliliter. So we put that here and we can cross off milliliters. Now we have drops per hour, and our question is drops per minute. So we got to figure out, well, we're in drops per hour, so how many minutes are in an hour, so we can cross these two off, right? So now we have those crossed off, and now we're in drops per minute. And now you just do the math. 200 times 12 divided by 2 divided by 60 ends up being what? So let me find my handy dandy calculator here, and we're going to calculate that. And when you type that in the calculator, I always do 200 divided by 2, which ends up being 100. And then I'm going to multiply that by 12, which ends up being 12,000. And then I'm going to divide that by 60, which ends up being 20. So it's 20 drops per minute, and that's your answer. Okay, so that's how you do it. It's really mainly dimensional analysis. Let's look at a few others just to make sure you guys understand it. A physician writes a medication order for a liter of D5W. Remember, D5W is 5%. Okay, 5%. And it's to be administered in 6 hours. If the nurse uses an IV administration with a drop set of 10 drops per milliliter, how many drops per minute, that's what we're going to calculate, would you deliver to the patient? So start with our volume over time. What's our total volume? 1 liter. And we're going to change that to milliliters because it's just easier. And we're going to infuse it how fast? What's our time? 6 hours. So 1,000 milliliters over 6. Now we want to get to drops per minute. So now we're going to take what do we have in here that we can get our milliliters to drops? Well, we have a 10 drops per milliliter. So we're going to put that here. We're going to cross that off. And now we got to get to minutes. So again, we're going to change our hours to minutes, 60 minutes in an hour. So we have drops over minutes. Now you're just doing your math. And when you do your math, your answer should be, I get 27.777. And on a drop, you always want to round down. That's the rule. You always want to round down on a drop, so our answer is going to be 27. You can't do 0.7 or 0.8 of a drop. So you want to round down so that they don't run out too fast or they're not dripping too quickly. So one thing to remember on drops when you're calculating drop sets is you want to round down. So our answer would be 27 drops per minute. So the next thing we want to talk about is calculating parenteral nutrition. And parenteral nutrition means supplementing nourishment to patients who cannot or will not take sufficient food or water through their mouth, or they put it in a port through their GI system. A lot of times you see this with patients that have been hospitalized and in a coma or non-responsive for a period of time. People who aren't eating are malnourished. Maybe an anorexic patient might go on a TPN. So there's the difference between PPN, which is peripheral parental nutrition, which provides partial nutrition support for patients who have a short-term hospital stay. I know, for example, my mom was on PPN because she was in the hospital for a period of time and she wasn't eating a lot and she needed a high amount of protein because she had a decubitus ulcer on her buttocks. So they were trying to get it to heal, so they put a lot of protein in it. Now, total parenteral nutrition provides complete and sustaining nutrition support for patients who can't receive food, water, or medication by mouth. So it could be somebody who has to bypass their esophagus, or they're comatose and they're not swallowing on their own. So, and they're going to be on it for a long period of time. So typically a large volume IV solution compound for multiple solutions such as dextrose, amino acids, sterile water, fat emulsion, electrolytes, vitamins, and minerals. So TPN-based solutions comprise of the three main things besides your sterile water for infusion. That's what SWFI, sterile water for infusion, stands for. But you have your dextrose, which is your sugar or your carbohydrates, your amino acids, which are your proteins, and then your fats, which fat emulsion, which is your fat. So it's looking at those four macronutrients that we get in most of our food. And then we're putting it to sterile water sufficient for infusion. So we add that to get up to the volume that we want. So total parental additives, a lot of times they'll do additives with it if the patient needs them, like they'll add in electrolytes, vitamins, minerals, and other medications such as insulin. So this is a formula that you're going to want to remember. So you want to take the total volume divided by the percent stock solution times the desired percent. So that's for your base solution. And then for your additives, you want your desired dose divided by the concentration on hand per milliliter. So these are a couple formulas you're going to want to remember when you're calculating TPN. So here's an example. A physician has ordered a 200 milliliter TPN with a base solution and additives shown below. What is the volume of each base solution and additive needed to make TPN? Well, I'm not going to do every single one, and you guys certainly can, but I'm going to just show you a couple so that you guys understand how to do this, and then you guys can do the rest. So let's start with, do the volume on the base solution of dextrose. So we want to figure out what our base should be. So we want to take our total volume, which is, let me get my 2,000 milliliters, right? And we're going to put that over our stock, our percent stock. So we have a 70% stock solution. So that's over 70. And then we're going to multiply that by our desired dose. And our desired dose is 15. And that's going to give us our answer. So 2,000 divided by 70 times 15 is going to give us an answer of 428. We're going to round it up to 29 milliliters. And that's what it's going to give you. So that's how you calculate that. You just want to put it in the formula, and it's going to give it your answer in your volume base. So I'm going to pull up 429 milliliters of the dextrose and inject it into a bag. So now I got to figure out each one of these other additives. So let's do additive. Let's say we're going to do sodium chloride. So how much of the sodium chloride are we going to use? So we want to take our desired dose divided by the concentration we have on hand. So the sodium chloride, we have 40 milliequivalents, and we're going to divide that by the concentration of sodium chloride on hand, which is 4. And 4 goes into 40 10 times, so that's 10 milliliters that we're going to end up adding. Okay, so that's how we're going to calculate. So right now we had 429 milliliters here. We're going to do 10 milliliters, and you're going to calculate each one of these according to your dose. And that's going to give you how you're going to make your TPN. It's actually pretty simple as long as you memorize the formulas. Okay, so you guys can go ahead and work through that and practice it and see what you get. And I will do it here on the side, and then I'll pull up another slide so you can see all of your answers. Okay? So what I would do here is I would pause the video and then do your math, and then unpause it and see if you got the correct answers. Okay, so here's the volumes I got for each one of them, and hopefully you guys got the same answers. So the amino acids or aminosins, I got 700 milliliters. The lipocin was 500. Potassium was 5 milliliters. Potassium phosphate was 2, and the multivitamin was 1. So when you add all of these up, you have a total volume of 1647. So 1,647. So now how much water do you add? You basically want to get it water sufficient for infusion. We want to get to a total of 2,000 milliliters. So if I subtract this from 2,000, I end up with 353 milliliters, and that is how much water I'm going to add at the end, sterile water, for infusion to get up to this volume here. And that is how you prepare a TPN.